to the next example, which is distribution center. Okay, so in here you have two factories called F1 and F2, and two depots, W1 and W2, right? There's a distribution center in the middle, and there's a possibility for factories to uh, transport their commodities through distribution center, or they can try not using the distribution center at all. When you look at the picture, there is a possibility for F1 to directly transport its commodity through line 4, but F2 actually doesn't have the ability to run without run its commodity without running through distribution center. So there's two factories, as I mentioned, and two depots. Each factory can supply the required products to any warehouse. The products are the same. And for two factories, the products are the same. And transportation can be carried out either directly or through the distribution center, and passing through routes incurs costs. This is the challenge for us, and the capacity of some routes is limited. This one, this line, and this line, the capacity is limited. So you cannot assign all of the transportation through this line, okay? Because there's a limit for this line. The question is, how should distribution be organized to minimize the transportation costs? So you have 7 links in here, 1, 2, 3, 4, 5, 6, 7, and each of them have their own features. When you are trying to look at the big picture, right? For example, for this F1 company, you can see it is producing 50 units, right? So when it's producing 50 units, the combination of line number 1, 3, and 4, the combination of its transported commodities should be 50, right? For this one, please try to consider at the arrows of each line, right? These 3 arrows are coming out of F1, but for F2, there is a 1 arrow that is coming out and 1 is coming in the F2. So for F2, it's an additional units of commodities that are just transporting through F2 to get to DC, the distribution center. So for F2, we have line 2, and we have line 3 with the units of additional units of the company, the F2 company, which is 40. That should be equal to line number 2, right? Distribution center, the flow for line 1 and line 2 should be equal to line 5, right? For the other ones is the same. For example, for W1 depot, you have the flow of line 4 and the flow of line 6, right? That are getting in the depot center, and you have the line 7, which is getting out of it. So you have line 7 minus the 30 units which are which is needed in the depot center in here, and the flows for line 4 and 6, right? After this, we should define our objective function and constraints, right? The decision variable is so obvious. X is xj, it represents flow for each link, and the objective function is to minimize the cost, right? The cost of each link is shown in here. $400 per unit, $200 per unit, right? So we try to write down the objective function in here. We just try to divide the objective function by 100 because all of them all of them have the same 100 multiplication in them, 100 factor in them. So it can be simplified in 4x1 plus 3x2 and so on. Okay. The constraints, there's three types of constraints. One of them is the last one, which is really obvious, that the flow for each one of these links should be positive. It should be non-negative. It's better to say non-negative, right? The two other ones of constraints are the flow conservation and the capacity of each line. The capacity is the thing that we discussed in here about line 3 and line 5, right? There's a capacity constraint for them. So x3 and x5, these ones has a constraint for each one of them, right? But the challenge is for the constraints of flow conservation, right? And I have told you in the slide number 34 that like for F1, you should have the flow for line 1 and 3 and 4, which can be said something like x1, x3, and x4 added together should equal to 50, and others are the same. Okay. So in CPLEX, when you want to write it down, first of all, you have the sets of indices, which is pretty obvious. Then you have the decision variable. It should be float plus, and this is this just releases this constraint in here. Just writing down the plus releases this one, and the other ones is defining the objective function. You have to define your objective functions always, but it is better to define it float most of the times, or there's some kinds of specific situations where you want to define the objective function in other types, and it's okay. In order to your need, you have to fulfill your need. Okay, and in here we have the objective function, which I discussed, and we are going to minimize our cost, our objective function, and the constraints that we talked about them, right? For putting down equal sign, for example, you want to x2 plus x3 to be equal to 40, okay? In here, you can't write down write down one equal because it's an assigned sign. You have to put down two equals. It's similar to Python or any other kind of programming languages. This software is the same with them. And the other kinds of constraints. And as you can see in here, I have just put this in here, and it's just for trying to explain it to you that we can have this one or this one in here, and there's no difference in between these ones. Now we are going to run this. This is the distribution center problem. So for running this, I'm just going to simply try to click on run this. So you can see in here, I haven't clicked on anything, but it directly uh, went on relaxation tabs, and it said there's a relaxation between constraint number 4 and constraint number 5. Okay, you can see this. So we will go to in here in conflicts, and we can see there is a conflict. But where is the confliction? So it's between conflict is between constraint number 4 and constraint number 5, right? And as I have told you, it will just try to relax one of these constraints at a time. For example, at first it will relax constraint number 5 and try to solve the problem with the first 4 constraints, and it will get the objective function, and then it will relax the constraint number. It will relax constraint number 4 and try it in this way, and whichever that are better for our objective function. We have a minimization, so whichever is like lesser than the other, it will choose that one. Okay, so in here, I think it relaxed constraint number 5. And you can see the solutions in here, well, that the solution of our objective function is 180. And we had x, which showed the amount of flow in each link that is represented in here. We had 7 links, right? So the flow in link 1, link 2, and link 7 is 30, and the other ones is 0.